The best image was taken on October 2nd by the high-rise camera on board the Mars Reconnaissance Orbiter. And unfortunately, the argument is because of the government shutdown, this data was never released.
We observe a truly unique and amazing interstellar object every day. In recent years, such visits have become commonplace for us, and yet each time they evoke both wonder and awe in astronomers and space enthusiasts alike. An object whose origin remains a mystery is flying into our solar system. Scientists still cannot say for certain where it came from, perhaps from the depths of our galaxy, where there are billions of stars and even more mysteries. This object has been designated 3I Atlas. So what new information have we learned about it? Of course, we would like sensational news, but unfortunately, today's media reports contain nothing particularly exciting. The fact is that the first planet 3I Atlas flew past a few days ago was Mars. We had hoped that the spacecraft already operating in orbit around Mars or on its surface would be able to make observations and send us detailed data. But we must be honest here, these hopes were rather faint. The thing is, these spacecraft were built to study Mars, not to investigate passing interstellar objects. They are not astronomical telescopes. Their mission is completely different. Nevertheless, despite this, engineering teams pointed the cameras of these spacecraft towards the sky and attempted to capture the passing 3I Atlas, but the object passed at a vast distance, millions of kilometers from Mars. The first photos transmitted to us turned out to be mistaken. Instead of the interstellar object itself, the images captured one of Mars's moons, Phobos. Such mistakes happen. Space does not forgive haste. And sometimes the lens simply looks in the wrong direction. Later, we did receive photos of the actual object, 3I Atlas. But alas, they are not of great scientific value. The optics of the Martian spacecraft are designed for entirely different tasks. A rover's camera, for example, is intended either for observing the ground right under the rover's wheels or for capturing the landscape a few kilometers around. Now imagine, we ask it to photograph an object flying hundreds of thousands, and in reality, millions of kilometers away. Of course, the images show a tiny speck representing 3I Atlas, but these images are of little use. However, they did allow us to refine the object's trajectory, even if only slightly, and this is important. We now know exactly how the object will move further, and we can anticipate the moment when it approaches Earth. For now, real large astronomical telescopes, both ground-based and orbital, will be our main observation tools. Space probes that happen to be nearby, unfortunately, cannot provide significant scientific material. Therefore, astronomers have to rely on their telescopes and also prepare new technologies specifically designed for studying such interstellar guests. In fact, studying interstellar objects has long been a problem. Every time such an object enters the solar system, and this is already the third case since 2017, we say, "Oh, we missed the chance again." All too often, scientists are unprepared, and technical means are not ready for such unique observations. However, scientists are already working on it. Special spacecraft are now being developed that will be placed not just in Earth's orbit, but in orbit around the Sun. They will lie in ambush and wait for the signal. An interstellar object is coming, and then these robots will be able to fly out to meet the object. The operating principle of these ambush spacecraft is similar to an air defense system. If a missile tries to chase a supersonic aircraft from behind, the chances are low. But if the missile is on an intercept course, heading towards the target, the chances of a meeting increase significantly. The same is planned for interstellar objects. They fly at speeds of tens of kilometers per second, 30, 40, sometimes 70 kilometers. Try catching them with conventional rockets. But meeting them head-on is quite feasible. An interceptor spacecraft will be able to fly close to the object, take photographs, collect spectral data, and transmit them to Earth. Imagine having a whole network of such spacecraft. They will be positioned on different orbits in different parts of the solar system, ready to respond to observers' signals at any moment. This will allow us not just to see the object as a tiny speck, but to study its composition, speed, orientation, and origin. Perhaps we will learn that 3I Atlas is something utterly unusual, an icy mass, an ancient piece of a planetary system from another star, or even a rare form of cosmic material we have never seen before. Each such flyby is a unique opportunity for science. Even if the photos obtained now seem modest, each new mission will be better prepared. Imagine a future where interstellar guests no longer go unnoticed. Spacecraft specifically designed to study such objects will be able to take detailed images, collect spectra, measure magnetic fields, and study the surface and atmosphere if present. We will be able to learn what this substance is made of and possibly discover new chemical compounds unknown on Earth. Scientists are working on this right now. Each new interstellar visit stimulates technological development, giving impetus to new observation methods and data analysis. We learn from our mistakes, improving cameras, sensors, and object recognition algorithms to be fully prepared next time. And and perhaps soon, interstellar objects will cease to be rare exotic occurrences and become part of our regular scientific practice. That is the task for the future, to turn random flybys into systematic, detailed research. And then every new visit by 3i Atlas or any other interstellar object will become a true celebration of science, a moment when humanity can touch the secrets of the galaxy and learn something that previously seemed unattainable.